Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge A Level Mathematics 9709 Mechanics. So, in our last video, we did some past paper questions related to chapter 2 of our mechanics syllabus. So, now we will be continuing with some more past paper questions related to this topic. So, let's get started. This question is from June 2014, paper 42, question number 2. A and B are 2 points which are 10 meters apart on the same horizontal plane. A particle P starts to move from rest at A directly towards B with constant acceleration of 0.5 meters per second. Okay, so A and B are 10 meters apart, and a particle P is moving from A towards B at, at constant acceleration of 0.5 meters per second square. Another particle q is moving directly towards A with constant speed of 0.75 meters per second and passes through B at the instant that P starts to move. At time t seconds after this instant, particles P and Q collide. Find the value of t. Okay, so first we will draw a rough diagram so that we can see what's going on. So let's say that this is point A and this is point B. So there is a particle at point A, particle P, and there is another particle Q which is at point B. Okay. So what we know is that the distance between A and B, that is 10 meters. Okay. And we know that at t equals to 0, u of the initial velocity of the initial velocity of P, which is represented by u, that is 0 because particle is at rest. However, it says that another particle q is moving directly towards A with constant speed of 0.75. So its initial velocity is not 0, but it is 0.75, and it is moving at constant velocity. So this is ub, and this is, that is uq, and this is up. All right. And we know that this particle is moving towards A, and on the other hand, this particle is moving towards B. So P and Q, both the particles are moving directly towards each other. Okay, so that is the initial situation. And also we know that the acceleration of particle P is 0.5 meters per second square. So that's the information that's given to us. All right. After t seconds, P and Q collide. Okay, so if I draw this situation over here, so this is A, this is B. So let's say that particle P is somewhere here and particle Q is somewhere here. Okay, so the time at which this happens, that is t seconds. Okay, we need to find what is this time. And what else is known to us? We know that the distance between A and B, that is 10 meters. So there is something that we can see from the diagram, that if let's say that the distance traveled by P is SP, then the distance traveled by Q should be 10 minus SP. Okay, because the total distance is 10. If the distance traveled by particle P is SP, then the distance traveled by Q should be 10 minus SP. Okay, all right. So keeping this in mind, if I write the data that's given to us. So let's say that the data about P, the data about Q. So S is equal to SP, and SQ, or just S, will be 10 minus SP. U is equal to 0. That's your initial velocity. Over here, u is equal to 0.75. Okay, that is constant velocity, right? Then over here, acceleration is 0.5 meters per second square, and t is equal to capital T. Over here, acceleration is going to be 0 and t is going to be capital T as well. All right, so now this is the data that we know. So based on the variables, we can use the equation S is equal to ut plus half at squared. So applying this equation to both of these, we'll have sp equals 0 because our initial velocity is 0, so this whole term becomes 0 plus half times 0.5 times t squared. So sp is equal to now 0.5 divided by 2. So that will be 1 over 4 t square, or you can just say 0.25 t square. Okay, so that's what we know about p. So let's do the same for q. In this case, that will be 10 minus sp equals to ut. So u will be 0.75, and here we have t minus, sorry, plus half at square. Since a is 0, this entire term also becomes 0. So that means I can say that 10 minus sp equals 0.75t. If I make sp the subject of the formula, so I would get 10 minus 0.75t. Okay, so this is equation number 1. This is equation number 2. I can substitute equation 1 into equation 2. So that would be 0.25 t square equals 10 minus 0.75 t. Okay. In other words, I can write this as 1 over 4 t square equals 10 minus 3 over 4 t. So I can multiply the whole equation by 4. That would help me in getting rid of the fractions. So this becomes t square equals 40 minus 3t. We will rearrange the equation. T square plus 3t minus 40 equals to 0. So now I need to find two factors such that when I multiply them, I would get 40. When I add them, I would get 3. So the factors will be 8 and 5. So we have 8t minus 5t minus 40 equals to 0. We will factorize t. So we will be left with t plus 8. Here we will factorize minus 5. We will be left with t plus 8. So t plus 8 times t minus 5 equals to 0. Okay, so that means t is equal to minus 8 and t equals to 5. Now definitely time cannot be negative. So t is equal to 5 seconds. That is our answer. Okay, so that is the first part. Number 2, find the speed of p immediately before the collision. Okay, so now we need to find out that what will be the speed of p, speed of particle p, immediately before the collision. So now we know that how much time has passed since the particle started to move. So I can write the data for p. So we know that the the distance, okay, even if we don't know the distance, we know that u is equal to 0. V is what we need to find out. Acceleration was 0.5 meters per second square, and now I have time which was 5 seconds. Okay, so now I can use the equation V equals u plus at. So that will be 0 plus 0.5 times 5. That gives us 2.5 meters per second. Okay, so this is the end of question number 4. Let's move to question number 5 now. All right. A cyclist starts from rest at point A and moves in a straight line with acceleration 0.5 meters per second square. Okay, so it starts at rest and then moves in a straight line with acceleration zero point 0.5 meters per second square for a distance of 36 meters. The cyclist then travels at constant speed for 25 seconds before slowing down with constant deceleration to come to rest at point B. The distance AB, that means the distance for the whole journey, is 210 meters. Find the total time that the cyclist takes to travel from A to B. Okay. Just to give you an idea of what's going on, we can just make a sketch of a speed time graph. Okay, so let's say that this is a speed, although that is not required, but just to give you an idea of what exactly is going on, because there are three stages of the journey. So it will be very clear once we have this the speed time graph. Okay, the first part of the journey is that it starts from rest, okay, and moves in a straight line with acceleration. So there is an acceleration. Okay, so we can draw this straight line. Okay, all right, so that straight line represents an acceleration. Okay, then it says the cyclist then travels at constant speed for 25 seconds. Okay, so this is 25 seconds. So let's say if this is T1, okay, then this is going to be T1 plus 25. Might have to extend this a little bit. Okay, then it says after traveling for 25 seconds at a constant speed, it then slows down, okay, with a constant deceleration and ultimately comes to rest. So that is your third stage of the journey. So what we do know is that this is 36 meters. Okay, we know that this, okay, we don't know the velocity. We know that this is t equals to 25 seconds, the duration for the constant velocity. And we know that the total distance, yeah, also we know that this is 0.5 meters per second square. Then we know that the total distance is 210. The distance AB equals to 210 meters. So this the purpose of this the speed time graph, okay, is just to give you an idea of what's going on. Okay, but there is a much better approach to, so that we can write everything in a bit more detailed. Okay, that would be let me draw the straight line. So there are three stages, right? So let me draw three straight lines, okay, in different colors, so it is quite visible then. Okay, now the first part of the journey, what do we know? This is your point A and this is point B. The total distance from point A all the way to point B, that is 210 meters. Okay, that's what we know. All right, for the first part of the journey, let's read the details again. It starts from rest. Okay, so that means u is equal to 0. Then it moves in a straight line with acceleration zero point 0.5 meters per second square. So the acceleration will be 0.5 meters per second square. Okay, then t will be t1. The time is not given, and the distance that was covered, so you can say that the red part, that is 36 meters from here to here. Okay, so that's all what has been given to us. All right, the second part of the journey, it says that it travels at constant speed for 25 seconds. That's it. That's the only thing that is known to us. So we can say that, okay, t2 is 25 seconds. Okay, and v is constant, so therefore we can say a is equal to 0. that is in this region. Then for the third region, we know that this is constant deceleration, but we do not have a value, and t is going to be t3. But what we know is that because the cyclist comes to rest at point B, the final velocity is going to be 0 meters per second. So that's all what we can deduce so far. All right. The question is, we need to find the total time that the cyclist takes to travel from A to B. So in the red region, we don't know what is the time. In the blue region, we know how much time it took. So this is already done for us. Then over here, we need to find what is the time. And once I know T1 and T3, I can add all three times. That will be my total time. Okay. So if I see the values which have been given to us, I know U, A, T, and S. So for the first part, I can use the equation S is equal to, let me write it like this. This is step one. So S is equal to 36 meters. U is equal to 0. V, okay, we don't have anything about V, so we'll just skip that. A is equal to 0.5 meters per second square, and T is equal to T1. So I can use the equation S is equal to UT plus half AT square. 36 equals 0 plus 1 upon 2 times 0.5 times T1 squared. Okay, so this will be 36. I can, okay, so this becomes 1 upon 4 T1 squared. So now what I can do is 36 times 4, and then I can take the square root. So T1 is equal to square root of 36 times 4. That gives us 12 seconds. Okay. All right. So that was our step number one. So now we have found out that, okay, the time that it took in this red region, that was 12 seconds. Okay. Coming to blue part, if I need to find out, uh, okay, for this particular part, it is already solved for us, right? But there are a couple of different things that we need to find here. Like, for example, we need to know what is the velocity, because that velocity will be the initial velocity in the green region. Okay. And also we need to find what is the displacement, so that I can find out what is the displacement over here. Because if you look at the green region, we literally have nothing. We only know that the final velocity is 0. So we should work out different variables so that ultimately we are able to find out time, T3. Okay. So in step 2, first we will find what is V. Okay. Using the information in the red part, we know U, we know A, we know T1. So that means we can find what is the final velocity. That final velocity will be the velocity which is constant in the blue region. So I can use the equation V equals U plus AT. U is 0, acceleration is 0.5, and time was 12. So that gives us 6 meters per second. Or if you don't want to use the value of t, because I mentioned previously that, okay, this is the value that we have worked out ourselves, right? What if this value is incorrect? You can use the alternate equation, that is v square equals u square plus 2as. Okay, so that becomes v equals square root of u square plus 2as. U is 0, acceleration is 0.5, and the displacement was 36. Taking square root of this, that would still give us 6 meters per second. Okay. All right. So that's our velocity, and that is the velocity that we have found in the blue region. Okay. What else can we find? We can find what is the displacement over here. So I can use the equation S is equal to U plus V upon 2 times T. Or this equation is also written in this form, half times U plus V times T. It is the same thing. So initial velocity is 0, final velocity is 6 upon 2, and the time was found out to be 12. So, sorry, my bad. The initial velocity is going to be 6 in this region. Okay, now we are talking about the blue region. Let me write down the values first, the data that's given to us. In the blue region, S is what we need to find. Initial velocity is 6. The final velocity is also going to be 6 because it is constant. Therefore, A is equal to 0 and T is equal to 25 seconds. So we can use any equation. Okay, so I'm choosing this equation. Okay, so I already did the working over here. So our answer to this is going to be 12 divided by 2 is 6. 6 times 12. Sorry, my bad. The time is 25, not 12. 12 was for the red region. So this will be 25. Okay, yes, now it's perfect. So the answer will be 150 meters. So this is the velocity. You can say the final velocity of red region, which was this one. And that final velocity is actually the same velocity throughout the blue region as well. Okay, all right. So that was our step number 2. Now we can move to step number 3. Step number 3 was the deceleration part. During deceleration, what is the data that's given to us? If I need to find S, okay, so we know the total distance is 210. The first part was 36 meters. Second part we just found that it was 150 meters. So now we can find out that during the deceleration, how much distance was covered. That was 210 minus 36 minus 150. So 210 minus 36 minus 150, that gives us 24 meters. Okay. The initial velocity will be the velocity that we found in the blue region, which was 6 meters per second. Final velocity is going to be 0 because the cyclist comes to rest at point B, right over here. So the final velocity is 0. All right. Finally, T will be T3. So now we see why it was important to work out the initial velocity and displacement, because now we are able to work out what is the time. So we can again use the equation S is equal to U plus V upon 2 times T. So this will be 24 equals U plus V, that will be 6 plus 0 upon 2 times T. So we'll be left with 24 equals 3T. Therefore, T is equal to 8 seconds. T3 equals to 8 seconds. Therefore, total time equals, now T1 was 12 seconds, T2 was 25 seconds, which was already given in the question, and T3 we just found was 8 seconds. So 12 plus 25 plus 8 equals 12 plus 8 is 20, 20 plus 25, that is 45 seconds. Okay. That is the answer to part 1 of the question. Let's move to part 2 now. Okay. It says that 24 seconds after the cyclist leaves point a car starts from rest from point A with constant acceleration of 4 meters per second squared towards B. It is given that the car overtakes the cyclist while the cyclist is moving with constant speed. So okay, after 24 seconds, okay, like let's say that when the cyclist leaves point A, you started the timer. Okay, after 24 seconds have passed, a car is now leaving point A, and it is traveling at a constant acceleration of 4 meters per second square, okay, in the same direction as the cyclist. Then it says that it is given that the car overtakes the cyclist while the cyclist is moving with constant speed. So that means that when the cyclist is in this blue region, okay, maybe somewhere here or anywhere, okay, that is the point when the car overtakes the cyclist. Okay, find the time that it takes from when the cyclist starts until the car overtakes her. Okay, now you can see that this is worth of 5 marks, right? And similarly, the previous question was also 5 marks, so that did involve quite some working. Similarly, in this question, first you should understand the scenario. At time t equals to 0, the cyclist leaves point A. Okay, all right. So the cyclist, it covers a distance of 36 meters, and it took the cyclist 12 seconds. After that, now it is in this region. Okay, while it is in this region and a total of 24 seconds have passed, that is when the car starts moving. Okay, now the car is moving, and at this point somewhere the car overtakes the cyclist. You need to find out what is that time from the very beginning. Okay, that is what the question is asking, that when the cyclist left point A is starting from that time. Okay. So first of all, I think it's a good idea if I take this diagram and write whatever is known to us, okay, so that we can have a clear picture. Okay, all right. So let me just modify this. We now know that t is 12 seconds. Okay, then in this region we know that v is 6 meters per second. Okay. And in this region we know that time is 8 seconds. Okay, what else? We know that the distance over here is 24 meters, and the distance over here was 150 meters. And we also know that acceleration is 0 because the velocity is constant. Okay, what else do we know? Yeah, I think that's pretty much. We know everything. All right. Now, our next step is going to be, first, let us write this down, that when, so let's say that this is your point A, this is point B. So when the cyclist is at the blue region, okay, this is your blue region. So the cyclist is over here. That is when car starts. Okay, and this is your cyclist at t equals to 24 seconds, and at t equals to 24 seconds the car hasn't started to move. So we know that its initial velocity is 0 meters per second. This is for the car. Okay, and we know that its acceleration is 4 meters per second squared. Okay, so car overtakes while the cyclist is still traveling at constant speed. All right. Now let us first write the data about the car and cyclist. For the car, let's say that the displacement of the car from from the point from point A till the point where it overtakes the cyclist, that distance is going to be S1. Okay, and for the cyclist, that distance will be S2. Okay, if I talk about time, now just imagine that the total time that we need to find, that is t. Okay, but for 24, for the first 24 seconds, ever since the stopwatch is started, remember, when did I start the timer? When the cyclist left point A. For 24 seconds the car did not move. After 24 seconds passed, then that is the point when the car started to move, right? So whatever total time was taken, we have to subtract 24 from it, because those 24 seconds passed and the car was not moving. Okay, all right. Similarly, for the cyclist, from the total time, we have to remove the time that was in the red region, because I'm going to find out I'm going to write the data related to blue region, right? The car is at this point. So I have to discard that for the first 12 seconds, okay, because that has already been taken into account in the total time. So I'm going to write t minus 12 seconds, because for the first 12 seconds the cyclist has already traveled, and now the cyclist is in this region, and we have to do calculations in this region. All right, now in this region, for the cyclist, its initial velocity as well as final velocity is 6 meters per second. So acceleration is 0. That is all the data that I know about the car. U is equal to 0 because it started at rest, and acceleration is 4 meters per second square. Now we know that distance traveled by the cyclist is equal to the distance traveled. In fact, I should write it like this: the distance traveled by the car is equal to the distance traveled by the cyclist. Now, the distance traveled by the car will be S1, right? But the distance traveled by the cyclist is not just S2, because remember, this S2 is the blue region that we are talking about. What about this 36 meters? We haven't taken that into account, right? So the distance traveled by the cyclist will be 36 plus S1. Oh, sorry, plus S2. Okay. Now, what is S1? We're going to use the equation S is equal to ut plus half at squared to work that out. So S1 is equal to, so the equation that I'm going to use is S equals ut plus half at squared. So S1 will be, since u is 0, this is 0 plus half into 4 t minus 24 whole square. So this becomes S1 equals 2 times t minus 24 whole square. Okay. And we can expand it, or okay, let's just keep it like this for now. I need to find out what is S2. So again, S is equal to ut plus half at squared. Since a is 0, so the second term half at squared, that will be cancelled. So we only have ut, which is 6 times t minus 12 plus 0. So S2 is equal to 6t minus 72. Now I'm going to use this equation. Okay, so S1 will be 2 times t minus 24 whole square equals 36 plus 6t minus 72. Now I'm going to expand this. This will be t square minus 48t, and 24 whole square will be 576 equals 36 minus 72. So that will be 6t minus 36. I can divide 2 on both sides. So t square minus 48t plus 576 equals 3t minus 18. Now you can bring both these terms to the left. So you have t square minus 48t minus 3t plus 576 plus 18, t square minus 51t plus 576 plus 18. That gives us 594 equals to 0. So now this is a quadratic equation. So we are going to use the quadratic formula. So minus 51 plus minus square root of minus 51 whole square minus 4ac. So that will give us two equations, 51 plus. So I'm going to work out what is the what is the answer to this part of the equation. So 51 squared minus 4 times 594, that gives me an exact answer of 15. So that means this that we were able to factorize, but the values were too big for us to factorize, right? Then we have 51 minus 15 upon 2. So t is equal to 51 plus 15 upon 2, that gives us 33 seconds, and t equals 51 minus 15 upon 2, that is 18 seconds. Okay, now remember, what was this t? The variable t was the moment the cyclist, our first driver, you could say, the one who was in part 1 as well, the moment the cyclist left point A. So after leaving point A, if 18 seconds have passed, okay, when the time was 18 seconds, because look, we found two values, right? At 18 seconds, the car did not start to move. The car only started to move after 24 seconds have passed. So therefore, our final answer is going to be t equals to 33 seconds. Okay, because at t equals 18 seconds, the car has not started to move. All right, so that is the end of our question number 5. And this was a very tricky question, okay, because the most tricky part over here is choosing this t minus 24, t minus 12, and these two equations, okay, and these variables, okay, that is what requires thought process. Okay, so you need to think a lot first of all before you can attempt the question. Okay, try to visualize the situation. You can see that I have taken a lot of time in explaining this question, and also I've drawn diagrams so that it becomes visually clear that what exactly is going on. Because one wrong move and you're going to lose your marks. Okay, so I hope that this question was something that you can practice a lot on, and inshallah, after you have practiced this question a lot, you will be able to understand that how to visualize these type of scenario based questions. Okay, so this is also the end of our chapter number 2. Okay, we have covered the lectures, and we've also covered some past paper questions. So take care. Assalamu alaikum.